Okay, today we are going to go over the section 8.4 notes, angles of elevation and depression. So, an angle of elevation is the angle formed by the line of sight in the horizontal plane for an object above the horizontal. Okay, and before I get started, if you haven't done the 8.3 notes, and if you weren't here that day, then see those notes and get those notes filled in and see that video. That will be much more helpful for you to take care of that first before trying to do the 8.4 notes. So again, the angle of elevation is the angle formed by the line of sight in the horizontal plane for an object above the horizontal. So if I look at this picture from the horizontal pointed upward at something, whether it's an airplane or a hang glider or the sun or whatever, that's what they mean by angle of elevation. Again, elevate means go up. Angle of depression is the angle formed by the line of sight in the horizontal plane for an object below the horizontal. Okay, again, depression means kind of down, and so in this case we've got from the horizontal pointed downward at something is going to be the angle of depression. And then the thing that you can notice here is that, think about what kind of lines these would be, this horizontal line and this horizontal line, and we can think of those as being parallel to each other. Okay, and if these lines are parallel and this is a transversal, think about what kind of angles these two angles would be. That goes back to chapter 3, that these two angles would be alternate interior angles, which therefore means that they are congruent to each other. Okay, so that's going to be a helpful thing to remember, and that's what it's saying down here. The angle of elevation and angle of depression are congruent because the angles are alternate interior angles. Okay. The other thing I like to point out is the fact that, sometimes you're going to be dealing with a right triangle, and the problem may give you the angle of depression. And there's actually two ways you can kind of take care of that. You can either use the alternate interior angles to think, okay, I know these two angles are congruent, so I can transfer that angle down here and use it within the right triangle that I've already drawn. Or you can think of the fact that if this is a horizontal line and this is a vertical line, then these two angles must add up to 90. So that's just another option, is to go 90 minus 38 to get this angle. And then you can do the problem in reference to either angle and you will still get the correct answer. Okay? All right, so let's go ahead and get that cleared and go ahead and start some of these word problems. So, here is the first word problem. So it says, from a lighthouse, the angle of depression to a boat at sea is 25 degrees. If the lighthouse is 105 feet tall, how far away is the boat from the base of the lighthouse? Base or bottom of the lighthouse. Round your answer to the nearest tenth of a foot. So you can draw a fancy picture, you can just draw a simple right triangle and label it from there, whatever works for you. On my notes, if you looked on Canvas, here was my kind of terrible idea of a lighthouse, and here is my very simple boat. Okay, but again, the whole idea is angle of depression. So from something up high down to something low is my angle of depression. So this is what it's referring to as my line of sight from up here to down here. Here's my ground or my water that's in the horizontal, and I'm assuming my lighthouse is standing up straight, so I'm going to put a right angle symbol there. Okay, now if I read back through the problem again, it says, from a lighthouse, the angle of depression to a boat at sea is 25 degrees. So from the horizontal, pointed downward at the boat, is this 25 degrees. All right, if the lighthouse is 105 feet tall, so here is my lighthouse. Okay, and how far away is the boat from the base or bottom of the lighthouse? So boat to the bottom of the lighthouse is referring to this length, which is x. All right, from there, round your answer to the nearest tenth of a foot. So in this case, these are two things that I know, and I know this angle, but I want to get that angle into the picture. So again, two different ways to think of it. You can either think of it as 90 minus 25 to get the 65, Or you can think of it as these are alternate interior angles, so if that's 25, that is 25, okay? Either way, that makes more sense to you. I think most people prefer to do the 25, but again, either option is fine. So I'm gonna go ahead and do this one like I did in my notes that are on Canvas, and I used the 65 this time. So I would just say whichever one you're going to use, I would just circle that so you didn't get confused of which one you're using. If I'm going in reference to this particular angle, then I would say, okay, compared to the 65, this X is opposite, and this 105 is adjacent. So therefore, with opposite and adjacent, just like we talked about in the last lesson, I think it's just helpful to keep writing that SOHCAHTOA. And I can see if I've got opposite and adjacent, then I'm going to use tangent. So over here, I can do my work. I can set up my equation. So I've got tangent of the angle that I'm dealing with, which in this case is 65. I'm going to write that a little bigger. I'm not trying to write a fraction here. So I have tangent of 65 is equal to opposite over adjacent. Okay, again, plug in what you know. So tangent of 65 is equal to opposite x over adjacent 105. And then just like we talked about in the last lesson, we just need to cross multiply here. But before I cross multiply, I like to put a 1 underneath the tangent of 65. Remember that tangent of 65 is just a number. So I can treat it like a number, or it represents a number. So 1 times x is x, and 105 times tangent of 65. Remember, it's important to write the 105 first. If you write it after, then it just gets more complicated typing it into the calculator. So if I go ahead and write it like that, that's the way I'm going to type it into the calculator. And then it says round your answer to the nearest tenth of a foot. And when you type that in your calculator, you'll get 225.2. And again, if there's units with your problem, then put units in your answer. In this case, it's feet. Okay, and again, then just see if your answer makes sense. You know, if you get a negative number that doesn't make sense, you know, just kind of make sure in reference to your problem, does that make sense? Okay, all right, let's go and do another one. We go ahead and move that up. We'll look at example 2. You can go ahead and read example 2 and start trying to draw a picture for that. So if we do that, it says that a plane takes off and rises at a constant 42 degrees from the ground. If the plane has traveled 940 meters through the air, how many ground meters horizontal has the plane flown round to the nearest tenth of a meter? Okay, so in this case, you know, again, you know, here's my airplane up here. I'm not going to try to draw the airplane. The lighthouse didn't go too well. So here's my airplane, and it's saying a plane takes off and rises a constant 42 degrees from the ground. So it took off down here, and then now it's here. So I'm going to go ahead and draw this path, all right? And it says that the plane has traveled 940 meters through the air. So I know how far it has traveled right now is that 940 meters. It says it rises a constant 42 degrees from the ground. And so here is my ground. And I can go ahead and complete my right triangle by doing that. Get rid of this extra little bit right here. And so again, this is my 42 degrees that it's rising from the ground. And it says how many ground meters horizontal has the plane flown. So in this case, we're saying what's the horizontal distance that the plane has flown. Sometimes they might be asking for the vertical distance. You just have to pay attention to the wording in the problem. Okay, so now that I have my picture labeled, then I can figure out if I'm going to use, again, sine, cosine, or tangent. So in reference to this angle, here is my adjacent leg, and across from my right angle is my hypotenuse. So A and H means I'm going to use cosine. And so I can do cosine, remember, of the angle, not a side length, is equal to A over H. Okay, I can plug in what I know. So cosine 42 is equal to x over 940. Okay, and from there, again, I'm just treating cosine of 42 like a number. So if I go ahead and put a 1 underneath that, then I can cross multiply. So from there, I've got 1 times x, which is x, and 940 cosine of 42. And when you go ahead and get that plugged in your calculator, you should get rounded to the nearest meter this time. So, you know, some of them we've been rounding to the nearest tenth, which like I have 698.6. But the directions on this one specifically say nearest meter, so nearest whole number. So I actually need to then round that to 699 meters. Okay, so just always pay attention to the directions on that. Okay, so next one is example 3. So let's get that moved up. There we go. Some technical difficulties. All right. So on this one, it says a plane has traveled through the air at a distance of 3,600 feet, not horizontally this time. Over the distance, it climbed 1,350 feet off the ground. What is the angle of elevation that the plane made with the ground? So this time they're looking for an angle. So let me just show you, one idea is that some people prefer to always just start with the right angle, right triangle, and then get things labeled from there. So I just want to show you that that's an option also. You can draw the picture first and then get the right triangle from there, or you can draw the right triangle first. So in this case, it says the plane has traveled through the air at a distance of 3,600. So again, we'll say our airplane is up here, and it started right here, and it traveled through the air at a distance of 3,600 feet. Okay, so its actual path was that far. Okay, over that distance, it climbed 1,350 off the ground. So that's the vertical distance that it's flown, 1,350. And now it's asking what is the angle of elevation that the plane made with the ground. So here we're looking for, like we talked about before, from the horizontal pointed upward at whatever we're talking about, in this case the airplane, that's what we are looking for, is our x. Okay, so in this particular case, again, we're using our SOHCAHTOA to solve for that. And in this case, we have our opposite, and we have our hypotenuse. And so in this case, O and H means we're going to use sine. So we've got sine of the angle that we don't know is equal to O over H. Again, I can plug in what I know. In this case, my opposite is 1,350, and my hypotenuse is 3,600. And in this case, if I go ahead and solve for x, then remember, anytime you're looking for the angle, that's when you're going to have to use the inverse. So in this case, we've got sine of -1 of 1,350 over 3,600. And when you go and get that plugged in your calculator, again, you're using that second button at the top left of your calculator, and then the sine button, but you should see this sine to the -1 appear in your calculator, and then 1,350 divided by 3,600 equals, and in this case you should get 22 degrees. In this case it's asking you to the nearest degree, so nearest whole number, so that's going to be 22. Okay, all right, 2 more. So on example 4, up here. So in this one it says you sight a rock climber on a cliff at a 32-degree angle of elevation. Your eye level is 6 feet above the ground, and you're 1,000 feet from the base of the cliff. What is the approximate height of the rock climber from the ground? So again, let's think about what is going on here. If I want to say this is my big rock over here, let's see. So here's my rock that somebody is going to climb up, okay? And there's a person over here that's standing, kind of watching this all take place, okay? and there's a rock climber that is up here on the wall, okay? Mine might not quite look like a rock climber, but you get the idea, okay? There's someone with their arms and legs on the wall climbing up. So what's going on with this is you sight a rock climber on a cliff 32 degrees angle of elevation. Well, your eye level is 6 feet above the ground. So the angle of elevation is starting from the eye length up to the rock climber. Okay, so here's where my right triangle is coming into play. Okay, so that's my right triangle, but we have to factor in the fact that the eyes are 6 feet off the actual ground, because here is our ground down here. Okay, so if we go ahead and read through this and get things labeled, we can see that you sight a rock climber on a cliff 32 degrees angle of elevation. Remember, that means from the horizontal pointed upward at something. So here's my 32 degrees. Your eye level is 6 feet off the ground, and you are 1,000 feet from the base of the cliff. So if you, this person is 1,000 feet from the bottom of the cliff, that length is 1,000, so therefore that length is 1,000. Okay, and the question is, what is the approximate height of the rock climber from the ground? Okay, so we want to know how far this rock climber is all the way to the ground, but right now we are just going to deal with finding out what this length is from here to here. Okay, we're going to use our trigonometry to figure out what x is, then we can answer the question of how high it is from the actual ground. We're going to have to factor in this 6 feet. So we just look at our right triangle for now. We can see that if we're in reference to this angle, that, you know, this is our opposite leg, it's across from it, and here's our adjacent leg. We are not using the hypotenuse this time. Again, if we write our SOHCAHTOA out, then again, here's O and A, so we're going to use tangent. So we've got tangent of the angle, which is 32. Very good, 3, is equal to opposite over adjacent. From there, I can plug in what I know. So opposite is x, adjacent is 1,000. And from there, I can go ahead and solve. So again, I can put a 1 underneath here, and I can cross multiply. 1 times x is x, 1,000 tangent of 32. And you can go ahead and get that plugged into your calculator. When you do that, you get 624.9, so go ahead and double check that. And then again, just don't stop there. Always look back at the question and think, have I actually answered the question yet? And in this case, approximate height of the rock climber from the ground. Well, we just found out how far this is. We need to factor in from here to here, which we know is 6 feet. So we just need to add 6 feet to this. And so now I know that I've got 630.9, and then pay attention, it says to the nearest foot. This is to the nearest tenth of a foot, so I therefore just need to round that to 631, and I want to put units with my answer, so in this case 631 feet. Okay, one more. So if we're going to get that cleared, now we are to example 5. So as I'm getting this moved up, you can be trying to get this set up. And this one's a little different because it's not, you know, it's not actual planes and people and all of that. So if we look at this one, it says triangle ABC has an altitude BD. And we know that this information that we are dealing with, you know, is going to have a right triangle in it, and that's where the altitude comes in. So if I go and draw triangle ABC, okay, and I go ahead and draw an altitude BD, so coming from B down here, and where it meets up is going to be a right angle, and I'm going to call that D. And it says if AB is 14, and BD is 10, find out what angle A is. You know, that's what I'm looking for. All right, and round to the nearest tenth. So again, same idea is if I'm trying to find angle A, then here's a right triangle, so I can kind of block out everything else. Dealing with this right triangle, I've got the opposite leg, and I've got across the right angle the hypotenuse. So again, if I look at my SOHCAHTOA, I can see that O and H, I'm dealing with sine. So if I go sine of the angle, which in this case is A, then sine is opposite over hypotenuse. Go ahead and plug in what you know. So opposite is 10, hypotenuse is 14, and from there, I know that I can go ahead and do the inverse sine because I'm looking for an angle. And so inverse sine of 10 over 14 gives you 45.6. And it says to the nearest tenth of a degree this time, and we're finding an angle, so we want to put our degree symbol there. All right, so if you have any questions with this, please let me know and I'll be glad to help you out.